Hi friends, welcome back. We are looking into verifying the correctness of the communication. So wherein we had two ways of solving this problem, either detecting the error or correcting the error. So now let us see how error can be detected. So the simplest way of detecting error is through something called parity check. So here we count the number of ones in the data and we decide so the type of parity we are going to use. So it can be either even parity or odd parity. That means the number of ones may be even or number of ones may be odd. So we decide before communication begins. So we both the parties sit together and decide so what type of parity is being used. Shall it be even parity or odd parity? So let's say even parity is decided. That means whenever the data is being communicated, so one group of data, say 101101011. So just count how many ones are there. 1, 2, 3, 4, 5. So totally 5 ones are there, which is odd. But we have decided that we are going to use only even parity. That means the data should always be even, and that's a problem we can face. So how to solve this? Yeah, to solve this, we can add an extra bit here, which nothing to do with the actual data. So add an extra bit, and this extra bit may be a 0 or a 1 depending on what is the actual parity. If actual parity is odd, so you add a 1 here, so that makes the total number of ones equal to 6. So that way that data now looks even parity. And if the data was already having 1, 2, 3, 4 ones, so that means already if it is even, then this extra bit you make it 0 so that it still remains an even. So this way a group of data, before transmitting, an extra bit can be added and made either 1 or 0 so that it will agree with the protocol we have decided, either using even or odd parity, and accordingly the data is sent. On the other side, we just count number of ones, and if we are working on even parity, and if we get this the data as it is, then it will remain even. So we accept the data without any problem. But if anything has changed, so in this, instead of 1011, if you get 100101, so what has happened is 123, that's a third, fourth bit of actual data has changed. It was supposed to be 1, we got a 0. So now you count that 1, 2, 3, 4, 5. So there are 5 ones. So that means the parity is odd. That means there is something wrong with this. So we detect that there is an error. So this way we can identify whether there is error or not. But the problem comes is when we have two bits are changed. So instead of this 1 0, if it becomes 0 1, then it still remains even. That means even number of changes will not change the parity and therefore not possible to detect. So that's one drawback we have with this simple system called the parity system for identifying the errors. So there are many other ways to improve this. So we see one by one in the coming sessions. Thank you.